We will continue talking in Unit 1 kinematics, and more specifically, in Unit 1 Part B, and even more specifically, talking about velocity. So velocity and speed tend to be two terms that are used interchangeably. Because velocity is a vector quantity, we have the arrow has a specific color so that we can identify what we are using for that. Remember that the colors themselves actually indicate, in some ways, what's going on. A lot of times, the displacement has a green arrow. Time, because it's scalar, usually it's just going to be written in black or just a non-vector color. But velocities are going to be red. Velocity arrows are going to be red, just like it has on the screen. And as the little mouse says, velocity is just direction or directed speed. Now, sometimes the direction is very simple, down the ramp or up the ramp. Other times it has more specific, such as northwest, southeast, just as we have talked about when we were talking about distance and displacement. Because velocity is a vector quantity, you will see velocity have sometimes a different equation. Sometimes you're going to see a change in x, which can also be, and velocity can also be written as velocity is equal to a change in y over a change in time. But it can also be written out as velocity is equal to displacement divided by time. And sometimes, to me, the values that are being used, such as y, x, d, and then sometimes we start using subscripts as well. That's what sometimes makes things confusing in physics. The x and the y actually gives us an indication of where it's located or where it's moving on an xy graph. Where just a displacement maybe doesn't give us that information. I prefer, for my personal preference, to use a subscript on the displacement for that indication. So then I think it adds maybe just a little bit less confusion with that. Now, again, in the classroom, we are going to do everything we can to make sure that we know the difference between velocity and speed. In our everyday life, the terms are used interchangeably. And that is, again, where general talk and science talk don't always make that connection. So let's do some more examples. A car travels 30 kilometers south in 10 minutes. Now, when we go through that, it says, what is the velocity of the car? Well, just like with speed, we're going to write out all of our knowns and all of our unknowns. Our displacement is 30 kilometers, and more specifically, south. The time is going to be 10 minutes, or 0.167 hours. What is the velocity of the car? Just like yesterday, we can use the circle equations or the triangle equations to help solve these problems. It does not matter which one of these you use, whether it be a circle or a triangle. Some teachers like the triangle because there's 3 parts and each part goes into a corner. I prefer the circle just because that's what I used when I was teaching 9th grade physical science. Or you can use the general equation that velocity is equal to displacement divided by time. Once we have our equation, we have our knowns, we have our unknown, we can now solve for what we want, the one question mark that we have. These are skills that are important because as we continue through the curriculum, we will find more and more complex equations. Our time is a known, and that is 10 minutes. We'll do the hours underneath. You can see that it does not matter which one or method you do. So 30 divided by 10 should be pretty nice and easy in that it's 3 kilometers per minute. And now because it has a direction, we do still need to say south. Now, the other one, where we have it in 0.167 hours, because that's not because 3 kilometers per minute might not be a number that's easily relatable. We get an answer by using our calculator, or maybe you can multiply in your head and divide in your head. We have 180 kilometers per hour. and that is moving fairly fast. Maybe a little excessive. A pitch is thrown 27 meters east in 0.7 seconds. What is the velocity of the ball? Again, just like before, writing down what we know, distance, and being able to recognize our displacement. Being able to look at and recognize our time. And know that the time of seconds, because it's a lowercase s, is not a direction component of south. That would be a capital S. It does ask us very plain and simple, what is the velocity? Using the velocity equation, we can now add our knowns into our unknowns. It's good practice to have our labels in our problem so that we can see what our answer should be labeled. After calculating it, we can see that we have 39.1 meters per second, given that those are the labels, and the direction is east. This might not be an extremely fast pitch, but it's moving. Somewhere around maybe a changeup, somewhere around a 60, 70 mile an hour pitch. So, sometimes the task of describing the direction can be easy. In some cases, it is the direction in which the object is moving. Sometimes it gives us a nice direction component to it, such as north, south, east, west. However, it can be, like I said, as simple as down the ramp. The number or the magnitude, how big the arrow is also kind of a part of it. It tells us information. The direction of the arrow tells us the direction of which it's moving. And that's why drawing what we have is so important. Making sure that we draw what we're seeing in the problem so then we can have an added visual representation. It's not something that I tell students to do just because to tell you to do it. It's something that even I do when I'm solving problems. So if it's something that it's good for me to do, chances are it's also good for you to do. So constant speed can be one thing, where it's just moving with a constant speed, doesn't change speed or slow down. Okay? Constant velocity means that the speed is also constant, but the direction does not change. The direction that the object is moving does not change. A constant direction can be a straight line, but if the speed or the direction changes, then the velocity is changing. So in the picture here, we can see the car is going in a circle. Because it's moving in a circle, is the speed or the direction, because in the circle, the direction is constantly changing. The direction is always changing. It's changing its velocity. The speed can be constant. It can never change. It can be not changing. And it's still going to have that aspect to it. There's a couple think about it's here. And the speedometer of a car moving northward reads 60 kilometers per hour. Passes another car traveling southward at 60 kilometers per hour. Do both cars have the same speed? And do both cars have the same velocity? The reason why they have the same speed is they're literally the numbers for these units are exactly the same. Okay? What gives them a different velocity is their direction that they have. Because their direction is different, they have different velocities. So we have to be careful when we read a problem, because some of the problems are going to give us one thing and some are going to give us another thing. And so we have to be careful about how the problem is laid out to us. So an object moves, it undergoes changes, just like we talked about on the previous day. During an average trip to, say, Mankato, you have to stop and or slow down through St. Peter. This gives us that same indication that the distance that's being traveled is 5 miles. However, because of stop signs and stop lights, people have to stop, which is going to slow you down and change your average speed. And because you're changing in speed, because you're slowing up, stopping down, going back and forth, your velocity is also going to be changing. So your average is going to be what it takes over the whole time period. So it would be 5 miles divided by 0.2 to give us the average of 25 miles per hour. That doesn't mean at any given time that is what they are, how fast they are actually going. That takes a little bit more.